This is FIRST Team 195. Our robotics team is part of FIRST Robotics. FIRST is an acronym standing for Inspiration and Recognition of Science and Technology. So FIRST has 3,600 teams all over the world. They're in 24 countries. Of the 3,600 teams, our team, Team 195, is typically ranked in the top 10 of 3,600 each year. Last year we ended at number 8.
So this is a robot sitting in front of you, and every year the FIRST organization comes out with a game, and we have 6 weeks to design our robot and actually build it. So this was done all in 6 weeks after the game was released. So this is our 2017 robot for the 2017 game FIRST Steamworks. And how that works is there's 3 different tasks in the game. One of the tasks is you have to shoot these wiffle ball looking things into this tower over here, which are located on these sides of the field. So this is a schematic of the field here. Then the next task is taking these yellow gear things and placing them on these little pegs around the field. And then the third task would be climbing a rope. So our 154-pound robot does climb a rope in under 4 seconds. Yeah.
Basically about our general design of the robot. So starting from the drive, we have a 6-wheel, 2-speed drive. So you can see here, it can move in low speed, a maximum speed of 11 feet per second, and then high speed 6 feet. So that provides us advantages because we have high agility when we need it. It's with speed, so we can have fast cycle times, but also precision and pushing power. So if we get into a pushing match with one of our competitors, we have a lot of pushing power. And then moving from there, we have a nice intake for the balls that you see. So when we're going around, our intake will come out, and then as Chris drives around, he'll suck up balls. Our intake was, in my opinion, one of the best in the world because we had a bumper wide intake, so no matter where we were going, if a ball hit the front side of our robot, it was in our robot. And we can actually hold 80 balls, which is like one of the most that a lot of teams can hold. And from there, you see we have our turret. So our turret has 500 degrees of freedom, so it can move from here and do a complete rotation around. And the key behind that was we didn't want to have a dead spot, so in the rotation. So if we're getting pushed around by one of the opposing alliance members, and we're getting turned, we wanted to be able to be locked onto the target no matter the orientation of our robot, so that we can shoot and score no matter what's happening. Our turret locks onto the target with vision, which Chris will explain later, but we can actually shoot 8 balls a second with about 90 to 95% accuracy, which is pretty good. So during the first 15 seconds of the game period, it's called the autonomous, and that's pre-programmed controls. So what we did was, one thing that we were really well known for was our 40-point auto for our hopper autonomous. So what we would do is we would go to one of the containers that stores balls, and we'd shoot and hit an important threshold for shooting balls in autonomous, which would give us the entire time in the driver control. So off the back of the robot, we have a gear pickup, so we can come in off the floor. And you see, so that's kind of, we call it a hybrid roller prong intake. So the roller, you can see, so if you drop it, so that will spin and suck in the gears, and then the prongs will come in, lock and grab it. So once it's got a hold of it, it's really tough to like let it go. So that's really good. So if we're ever getting like pounded again, the gear won't fall out.
Why'd you make it so small?
Because we wanted to make as much room for the hopper as possible. That whole assembly is this big. And then for our placement, we have a pressure pad, so when the spring hits a Lexan plate, it'll trigger 2 limit switches that will then run a program to deploy the gear completely autonomously. So he's going to drive up and he's going to say, all right, I'm ready to place the gear. So once he hits the peg, we have really low battery right now, but so everything together works to throw the gear on the back of the peg, because what happened in the game was there was actually a person in an airship who had to pull up the gears, and if they weren't on the complete back of the peg, gears would often fall off, which was not good. And then the match, when we're done shooting balls and ready to go climb, we deploy our climber so it flops down, and this we have metal Velcro, so that would lock onto our rope, and then we'd start to spin up and climb the rope. So the benefits of having this assembly here is that as it wraps around, it gets 1 to like 3 wraps, and then it'll start to pick up the robot. So that ensures us that we'll climb every time as long as we get the rope, and we can climb in about like 3 seconds once we have a hold of the rope.
So programming-wise on the robot, there are 2 computers that we have. One being this gray box right here, the other being the green circuit board beneath it. This one is called the Robo Rio. it's the computer we're given to use, and it's how we control the robot and everything's run. And then the computer beneath it is what we use to process our vision, which is through this camera here. So that's probably the most interesting part of the program. It's like the robot can see the target with this camera between these lights and align itself and keep itself aligned. Last year we used LabVIEW, which I know you guys have used in the past, and this year we moved to C++ for more fine control over.
As you can tell, this was a very complex game this year. We had 2 different game pieces, plus we had to climb a free hanging rope at the end of the match. So going along with that complex game, like Jake explained, we had a very complex design. One of the hardest things to design on the electrical sub-team was this full force spring here, which allows all of that degree of rotation on our turret. And in addition to that, we only have 6 weeks to build this complex robot, and electrical got 2 days of that. So at the very end of the season, you can see all of the electrical on the robot, and we also do all of the pneumatics, which is the air pressure. So we have all of our motor controllers, our solenoids, everything underneath this giant plastic hopper.
The scouting system, where we have it electronically on tablets, and the students will sit up in the stands and just punch in all the numbers. Basically, how many balls this robot scored, did this robot climb, did this robot do this many gears, and then from that we'll determine if the robot's reliable. And when it comes to the elimination rounds, we'll see which one will complement us best and pick them so that we can have the best chance at winning.
Filled with all of the outreach that our team does, from the youth in our community to the veterans to our fellow teammates. We've opened fields, we've shared data. So our outreach, we really value our outreach. And
Countries. We mentored a rookie team in Turkey last year. Israel. We helped out Israel. I don't know who else did we. The program is expensive to run, and it's thanks to companies like Ametek, Hayden, Kirk, Pittman. That's your new name, right? That keep this program going for these kids.
From Team 195, thank you for your support. Yeah!